Today we're talking about homework 8, problem 9. The problem is show that f x1, x2 is the Markov chain. Then it is statistical defined, determined by its second order probability methods. P xi equal to xi, capital Xj equal to xj for any ij equal to 1, 2. And in the clues to homework A, through the lecture, we can see that there's a discussion. A stochastic process is a function of two variables, t and n. For a specific outcome at I, x, t, I is a single deterministic time function, which is called the sample or realization of a static process. And for a specific ti, x, is a random variable. For a pair of specific xi and tj, xti, is a mirror number. The random sequence discussed in lecture 10 and describe time stochastic process, and for first and second order statistics, in order to specify a random variable, we need to know its distribution. Fxx equal to p x ever smaller equal to x. The meaning of x-axis is that for a given real number x, fxx equals the probability of the event x smaller equal to x, consisting of all outcomes such as capital X is smaller equal to x. For a stochastic process xt, the distribution function in general depends on t. Xt equal to p xt smaller than x. Xt is called the first order distribution of the stochastic process xt. In order to specify a stochastic process, it is not enough that we just know its first order distribution function. And there's a graph below. And if we have two random variables x and y, in order to specify these two random variables, we need to know their joint distribution. Fxy equal to p, x smaller equal to x, y smaller equal to y. In order to specify a stochastic process xt, we also need to know the joint distribution for two time instances. For given two time instance t1 and t2, let us consider the random variables xt1 and xt2. Their joint distribution function is defined as fx1, x2, t1, t2 equal to x, t1 smaller equal to x1, xt2 smaller equal to x2, and we call it second order distribution function of the stochastic process xt. So p capital xn plus 1, xn plus 1, x1 equal to x1 to capital xn equals xn equal to p capital xn plus 1 equal to xn plus 1, capital x1 equal to x1 to capital N equal n xn 1, p x1 x2 to xn equal to p cap x1 p x2 x1 p x3 x1 x2 p xn x1 x2 to xn. Markable probability p xi p1 to x1 i1 equal to xi xi1 p x1 x2 to xn equal to px1, px2, x1, pxn, xn1, and when m bigger than n, pxn plus 1, xn plus 2, 2, xm, x1, x2, 2, xn, pxn plus 1, pxn plus 2, 2, xm, x1, x2, xn, and p capital Xn plus 1 equal to j, capital Xn equal to I, equal to pij regardless of n, otherwise inhomogeneous. And then we can get v equal to 1 to the n, and px1, py, pxj plus 1 in the case of homogeneous chain j equal to 1.